In this video, we're going to take a look at what happens if you calculate a correlation and your correlation is close to 1 or -1. And again, keep in mind that means that my data points are very linear. They look like that there is a causation. It looks like I've found a connection in my data in my study. And let's talk about what that could mean. And the first thing to discuss is that could mean that there is a direct cause and effect going on. It's possible that one variable that I'm studying is causing the other one. And for example, as you can see on the screen, if I put fertilizer on my lawn, that will cause my lawn to be more green. That's just a natural cause and effect relationship. And again, that's assuming that I continue to water it as I normally would. And I like to represent that as a picture because I think it will help us understand some of the other situations. So this simply is just showing that if I apply fertilizer, it will directly impact my lawn's greenness, if you will. Okay, so that's direct cause and effect. It's possible that if my correlation is 1 or -1 or near 1 or -1, that I do have a direct relationship, a cause and effect going on. However, many times, people wrongly assume that since there is a good correlation, they wrongly assume that there is a direct causation, because there's a lot of other situations that could be going on here. So we're going to analyze a couple of them. Okay, one thing is called a common response, and a common response brings up a new word, and that is a lurking variable. And we have to be very careful. If we have a good correlation, it does not always mean that we have a straight connection, that we have this awesome result. We have to be very careful. Okay, it might appear that we have a cause and effect relationship, but there might actually be something else going on. Common response is exactly what it says. It says there might be the things that I'm studying might be commonly responding to something that I'm not looking at, and that's the lurking variable. Lurking variables are things that are going on behind the scenes, lurking behind the scenes, and I didn't see it, I didn't study it, I didn't look at it. For example, if I were to do a statistical study, I could find that countries that have a high percentage of cell phone users tend to have higher life expectancies. So if I did that statistical study, looked at life expectancy and maybe percent of population that has a cell phone, I would find that connection. More cell phones equals higher life expectancy. If I didn't make a wise conclusion, I could write this big article that says, hey, more cell phones equals higher lifespan. So what is the conclusion? Let's buy a lot of cell phones and donate them to people that have lower lifespans. Hopefully you and I both know that just me handing someone a cell phone is not going to make them live longer. So what's going on behind the scenes? Back to a picture that I think really kind of tells it all. There's something hidden that's actually affecting both cell phone users or cell phone owners to rise and life expectancy to rise, or better general health to rise. And that is basically technologically advanced. Countries that are more technologically advanced tend to have more cell phone users and have better health simply because the technology is there to push both of them higher. So the data might show that they're both rising. The reason they're rising is there's something going on behind the scenes that I really didn't look at when I did my study, and that is that more technology increases both of these cases. Another example for common response, and again, remember that means that I'm studying two things, and it appears as though one thing is affecting the other, but I missed something else, a third thing, a lurking variable behind the scenes that's actually affecting the two things I'm studying. For example, are you aware that when ice cream consumption increases, that the number of swimming deaths also increases? I could do a study and I could show this. Ice cream consumption, as it goes up, the more ice cream we eat, the more swimming deaths occur. It can be shown. So a conclusion we could make is, well, let's not sell any more ice cream. Clearly, ice cream leads to death. Not true. There's something else going on behind the scene. Can you think of the third thing going on that I didn't mention? There is something that's actually affecting this. There is something that generally creates more ice cream eating, and there is something that creates more swimming deaths because more people swim. And that has to do with the season or warmer weather. There's a third thing, a lurking variable, warmer weather, that's causing both of those to rise when in fact neither one of them has anything to do with the other. Another thing that we need to talk about here is coincidence. And coincidence is exactly what says it is. It's simply just happened. They don't have any impact on each other necessarily. It just happened. The discovery you made was just simply coincidental. For example, divorce rates and gas prices have gone up over the past decade. Does it mean that the more divorces we have, the higher the gas prices are going to go? No. Does it mean that if gas prices go up, divorce rates are going to go up? No. Some people might say that higher gas prices might create more stress, but in general, they have nothing to do with each other. It's just kind of coincidence that they have both